Okay, so here's the first problem that we're gonna check. By far is one of the most complicated of them because there's a lot of math involved. So, well, let's check it like calmly and see how this works. Okay, so there are two people that are like in the glacier or somewhere in the mountains, and Paul just like falls on the edge, and well, he goes down. Okay, and he's tied to Steve, who has a climbing axe, and this guy over here. Well. Well, well, both of them slide down and there's no friction, we need to know the acceleration they have before they just like kind of stop. Okay, thing is that, well, we first have to do the free body diagram. Okay, so, well, let's see. We're gonna start at the center of pole and we're just gonna draw an arrow going up, and this is the tension, and it has a weight just going down. That's Paul's weight. Okay, now for Steve, we're gonna have like the shift axis once again. So this is gonna be like going up. There's gonna be a tension going right. That's the normal force. And we're gonna have the weight going here. Okay? And this is gonna be the angle theta. Okay, so now we need to settle the equations. Equations for, I'm gonna call this 1, and this one over here, we should like write it number 2. Okay, so 1 should be um, the sum of all the forces in X. It's gonna be the tension. Whoa. You have tension plus the weight sine of theta, and that's it. And that's gonna move, so it's gonna be equal to mass times acceleration. Okay, and the forces in Y, it's gonna be like normal force minus weight cosine of theta, and it's not moving in the y-axis because we shifted it. So that's the thing we're gonna do, and this thing is gonna be equal to 0. Okay, and then we're gonna write it for number 2. And well, there are no forces in x, would just so we can just say that the sum of all the forces in x is gonna be 0. And let's write now all the forces in y, and it's gonna be the tension minus the weight of Paul. Here it should be like, what was the name? Steve. Okay, the Paul, and this is gonna go down. So this is gonna be minus mass times acceleration. Okay, it's my negative because it's going down. Okay, so from here, what we have to do is to find the acceleration. If we just like notice, there's just like they share the same acceleration, they're moving down, but the chord is exactly the same. So this is exactly the same root. Okay, so the tension is exactly the same. So we can just like solve for t in each case and, I don't know, equalize both equations and then solve it. So let's do that. Okay, so from the first part, let me change color. Now let's say color, it's okay. T, it's gonna be plus the weight of Steve, the sine of theta. It's gonna be mass of Steve, sorry, times acceleration. Okay, so from here we just like T, it's gonna be equal to mass of Sam. That's gonna be acceleration plus the gravity sine of theta. Okay, now then it goes for Y. They're gonna go, I don't know, tension minus the weight of Paul. It's gonna be equal to the mass minus the mass of Paul times acceleration. And tension is gonna be the mass of Paul times the gravity minus acceleration. Okay, so that's the thing. So from there, we just like we can do stuff, and we just like make this equalize these two equations. So let's keep on going. I'll take green. Okay. So from here we just can say the mass of the Steve times acceleration plus gravity sine of theta. It's gonna be equal to the mass of pole, gravity minus acceleration. Okay. So we want to find the acceleration from here. So this thing is gonna be like a little bit weird. Okay, so we're gonna get all the acceleration on one side and all things that have like um, gravity on the other side. Okay, so here I think I messed up something. Yeah, here it's a negative. That's a negative. Yeah, sorry for that. Well, let's say that from that we just have the acceleration. That's gonna be the mass of Steve plus the mass of Paul. It's gonna be equal to the gravity. Um, that's gonna be the mass of Paul minus plus. Sorry, so this one is -2. Plus the mass of Steve sine of theta. Okay, so there you go. So we now solve for A, and we're gonna have acceleration. It's gonna be gravity, uh, mass of Paul plus the mass of Steve sine of theta over the mass of Steve plus the mass of Paul. Okay, so there you go. Okay, so we substitute values. We're gonna have like 9.81. That's gonna be 92. Sorry, and plus the mass of Sam. That's 78. Sine of 15. So this is going to be 992 plus 78, and this is gonna be 6.47 meters over second squared. Okay, so that's acceleration. We need to find now the tension of the rope. As I told you before, as it is the same rope, we can assume that it's just like the same one. Okay, so I'll get from the simplest one that I got. So I'll get it here because the other one has a sign, and I don't like using trigonometric things. So I'm gonna say that that is gonna be the mass of Paul. That's gonna be 92 times 9.81 minus the one I just found, that's 6.47, and that's gonna be the total tension. It's gonna be 306.92 newtons. Okay, so that's it.